Good morning, everybody. I'm sorry about the late post here, but as we have had some technical difficulties getting the internet to work super well in my house today. I'm not sure what's going on. All right, so we're going to talk about electricity. I can't get rid of this, although that's not really an internet issue, but my internet is just very, very slow to a crawl at times. So I do want to spend a little bit of time in doing some projects with electricity. I think it's invaluable. I think in a modern world, almost everything we make has some involved with electricity, and it's not a surprise. I think of electricity almost as magic. If you're a Harry Potter fan, and hopefully even if you're not a Harry Potter fan, you appreciate they make magic in there. And if you saw any of the read the books or saw the movies, you saw they had to work hard in school to learn magic. Well, just like that, it's not always obvious what's really useful in electricity is not always obvious, but it is surely powerful, just like magic. And if you work at it, just like magic in the movies, you can do incredible things. And honestly, unlike the movie that's made up, this one is just learn a little bit, work at it, take your time, understand it. It'll come to you, and then you'll be amazed at things you can do with it. So let's talk about a description of electricity, because electricity is one of those wild things that you really can't see it. All we really do is see the effects of electricity current moving back and forth, or static electricity when lightning blasts out sky or it's wintertime, you get a shock. But we're going to talk about, so we're talking about current, and we're talking about direct electricity, electrical circuit, for example. We can describe the current as the amount of electricity, amount of flow. Voltage being that pressure. See those black arrows? It's how much we're pushing the current through there. So voltage times current gives us what's the important part, power. Resistance, sometimes you get too much power, you'd break that string. So we'll have a valve for, think of resistance to control that power that's coming out of there. All right? So that valve lowers the pressure. There's your current. How much push, the resistance works against it. So just for right now, for the next couple laps, just let's use that analogy. And the one thing I wanted to do is you all should have two things. You should have gotten a black box of snap circuits, and you should have gotten a foam airplane. So we're going to be working with our hands the rest of the way out. So please build project 1. Now you're saying to yourself, where was project 1? Well, project 1's part of this. You got, and in there you have books. I might several of these, but project 1 is going to be on one of those books. They got some separate numbers. Let me pull out my book right here. I have it out. So you want project 101, the book that says project 101. The cover's ripped off mine because I gave it to you all. And that's the student's book that I was just showing you. This is a student's book. My cover's off of it. You have that, but you also have projects 101 here. Student books, if you don't understand what I do, will also help explain things. So that's that. Now, as far as this goes, remember there's a couple sections in there. There's the top section you can see right there. One of these probably somewhere in there, but there's a foam section, just so you know, so you don't think there's nothing underneath it. See it right there? There's the foam section. And then the parts for the foam section, there's more parts underneath there. So make sure you have all three as you're looking at this. What the snap circuit does, snap circuit just does that. You take this with the little nubs up, not down, but the nubs up, and you snap it in there. And then the blue parts that you can see on the drawing there, on this drawing right here, are like, think of them as wires. So I want you to build this right now. And then click the slide switch. I say push the switch, slide the switch, I suppose is a better way to say it. Slide switch is down here at the bottom. Here, S1, slide switch. You're doing this to it, on and off, on and off. You also have something if you want to try the other side. Now, this is called a momentary. Slide switch is permanent. This is just as you click. I don't know if that helps. There we go. This will help us see things better. All right? All right. Now, so there we go with that. Let's go on to the next part. Hopefully this will load up. See, this is the kind of thing that's been driving me crazy all day. So sadly, I'm going to have to go to this solution. I have no idea why it doesn't want to do that. So I'm going to go to here, which is not as good as if I could put it in presentation mode. Not sure why. I know. I have some reasons to suspect that we got issues with our slow internet, that when I'm both recording a webinar and trying to do this, it creates problems. All right, so here we go. Now I want you to flip the battery. Positives now at the bottom, negatives in the top. And then tell me if there's any difference on the light bulb. Again, hit the switch. Write down, is there a difference? If so, tell me what the difference is. All right. Now let's go on to the next step. I want you to get a meter in here. I'm going to get the meter. It looks like this. Make sure it's pressed with the left switch here. You can go either way, press it there. And make sure you're putting these things back. It took me a while to sort these all out for you, so I'd appreciate when you return them, they're all nice and neat. Okay? Go ahead and run that and record the value for your meter. Does that make sense to everyone, I hope? Go ahead and do that. Then, let's go to the next screen. Don't worry off to the sides here. These are just parts that I use my slides to pull out. This is the part I want you to concentrate on. Do, right here with my arrow, go ahead and make the slide switch again with the motor. Which way does the fan spin? Clockwise or counterclockwise, like the hands on a clock? Go ahead and build that. I'll pause this so you can start up. Okay, now you've built that. Let's go ahead and go to project 3. The next, let's flip it like we did last time with the lamp. Positives down here, negatives here. Flip the switch. Tell me what happens. Is it going clockwise or counterclockwise? All right. Next thing. You've done that. You've tested it. Hopefully you've switched it. Next thing, put the meter on there. Turn the fan on. See what the meter does. All right. Record that and that handout I gave you, because that's what I want to get. I want to receive back from you. Now, final thing, let's do the LED. Note it's really important. The positive on the end of this LED connects to the positive side of the battery, the negative, the negative. Go ahead, turn that switch on, switch we moved up there. Going to 3. Now you've done that, you're going to do just what we've been doing. We'll flip the batteries. So now the positive goes to the negative side of this LED, and the positive goes to the negative side of the batteries go to the positive side of the LED. The negative side of this LED goes to the positive. What happens when you press the switch? As you can imagine, we're going to put the meter on it, but I want you to switch the LED back, where the positive connects to the positive here, the negative over to here. And then measure on the meter. Then I want you to tell me on the sheet, compare how does the direction of current affect the lamp, the motor, the LED. How does the direction of current, all right, well, it's also known as polarity, the lamp, the motor, the LED. Next question. Which draws more current? Notice the word draws. So the current will come in as much as you ask for it. So the lamp or the LED? Why would switching to LEDs be good for the environment and save you money? Now, the next thing we're going to do is, so once you get that answered, the next thing we're going to do is talk about resistance. So I want you, basically, same thing before, positive, positive, and LED, negative, negative, if that's what you've got, making sure the LED works. All right, so make sure, going back to this, all right, so we got the light there. All right, so now so just in summary, because we covered 3 things that I want to make sure we have. I want to know, first, changing direction of current, because when you flip the positive and negative, that's what you're doing. How does that impact the lamp, the motor, the LED? All right. Right, my Mac's about out of memory. That's great. All right. What about resistance? Well, also, let's go here. What am I back? Sorry, guys, on this. I'm getting interruptions. You won't see it, but I'm getting notifications. I'm trying to keep off my computer. I apologize. Also, in terms of which draws more current, an LED or a light bulb, understanding that, which one's going to be better for the environment. Next, we're going to go on to resistance. We said there was current we worried about, and resistance and voltage. We kind of control, a lot of times we'll control the amount of voltage with resistance. So let's try resistance first. An indicator of our voltage is going to be that bright LED. What I want you to do is, if we do it one with an R1, see what the LED does. Then R2, then R3, R4, R5. You have, on your whole list of these, there's one that says R1, R2, R3, R4, R5. That's what we got. All right. As I increase resistance, what does the LED do? If the current stays the same all times, the same in all cases, then what does increasing resistance do to the voltage? How do we know? What's your indicator? So that's what we'll go to today. So get to that. Make sure you clean everything up. You put it back when you're done. All right? Thank you very much, folks. I'll see you Wednesday. But I'll check in tomorrow at 9 o'clock. And if you've got a problem or something, we'll go ahead and get it squared away. All right? Thanks. Bye.